All right, welcome back, guys. So for this video, I think we will be talking about how I did the core effects for the blue stuff. This core thing in the center of the shockwave. So there are really only two layers in this effects, which is just the swirling particles of the core, and we've got this really jumpy, erratic, lightning looking thing. So if we have a look at our reference, really it's only even just a sphere for this, for the core effects. There's not a lot happening. It's also got this wobbly movement to the spherical shape, which I think adds a lot to the feel of the dynamics, because it makes you feel like the core is really unstable, and that's what I really wanted to get. All right, let's have a look at the Houdini file. So the blue stuff would be under the blue sphere core, and that's where the lightning thing and the swirly bits happen. So yeah, the particles were actually rasterized into the particles were rasterized into this volume here. All right, so let's talk about the core now. So first of all, I want to talk about how I did the lightning, the jumpy lightning thing. So it's really simple. I'll just quickly explain how I generated all those lightning curves. So we just put down a grid for now as an example, and then scatter a bunch of points. So essentially, I'm just using the node called find shortest path to generate all these lines that look like capillaries or veins or stuff, to make the lightning shapes. So how I did that is just scattering a bunch of points into the geometry, and then putting down the connect adjacent pieces to connect the points, with a bunch of polylines, and then we could literally right now put down a find shortest path node, but before that, let's put down a group expression SOP, so that we could identify our start points and our end points. So with our group expression SOP, we set it to a point, and on the drop down on the vexpression, we can go down to this 30% chance. So it's just gonna say, let's group a bunch of random points, put them in a group called start, and we only take 30% of the points of the incoming geometry. So this is what it does. So this is technically the percentage of our grouping. So if we put down a percentage and then take this on, now we can specify how much points we want to be in the start points. So I think for now I just want to have it in a really low number, because I just want essentially 2 to 5 or 2 to 10 points. I think that's fine for now, just to visualize things a little bit better. There. So now we've got the start group. We could use that into our find shortest path. So we put down the start group here, so and like that, and then under endpoints we say all the points except for the start, and under output paths we say from any start to each end. So it's saying we start from any start point that we specify here, and on to each end, which is each of the end that we specify here, each of the endpoints. So now it's literally branching off from our start. Let's call them the origin points from the start points, and branching off to any of the other points that are not the start points. All right, so we get this cool looking capillary, veiny thing. So what I want to talk about is the breaking up this kind of look, where you see how the edges of these, the connections between different cells, if you could say, you can see the border really clearly. They look like a Voronoi kind of pattern. So how I broke that up was by using this point cost attribute. So we can specify down here an attribute that we want to use to break up how we travel along, how we look for different points. So we do that by using a point bob and say break up path cost. So inside, we just put down some noise, any random noise, and let's fit that into some number. We put that in there in CD, and then we check geometry spreadsheet, and let's bypass this first so we can see how the range of our turbulence noise look like. So it goes from 0.001 to 0.5. So I'm just gonna set my min to 0.001 to 0.5 and unbypass that, and cool. So I'm just making sure that the values coming out of this are 0 to 1, coming out of the noise. Now we can export this value out into an attribute. Any name will do, but I will just put it as path cost. And with this path cost, we can put that in here. And if you just look at the viewport, it creates this really cool broken up. It's harder to see the borders of each of the cells now with the path cost attribute. It's because it's trying to avoid, it's trying to find, like, it's basically like a avoidance map for the find shortest path. So if we just change the frequency of our turbulence noise, you can see how the avoidance pattern look like, and very cool. You can see how the borders are breaking up. All right. So next up is pretty simple. So by default, the find shortest path outputs this cost attribute, which is extremely useful for us for what we need to do, because we'll be using this a lot for coloring, for applying the width of our lightning stuff. So if you just put down the cost here and visualize it, we can see that the cost attribute is actually a 0 to 1 value, not a 0 to 1 value, sorry, it's a value that goes from our start point to each of their ends, to each of the ends. So we will be using this for many things. Like for example, I would use it for adding some noises along the border, along the ends of our lightning. So if I put down a mountain sop, and before the mountain sop, we put down an attribute remap, and I want to remap the cost attribute into an attribute called blend. If I just set this to compute range, it will compute the range of the cost attribute for me, and the output min will be 0 to 1. And this new remap value will be placed inside a new attribute called blend. So if you see, I don't have any blend attribute here. But with this attribute remap, it creates that blend name for me, blend attribute. So I'm just using the mountain sop to add some breakups to the thing, but I don't necessarily want to break up the origin of our veins of our lightning. So with the attribute noise sop, we get this pretty cool parameter which blends between the original input geometry into the new noised up version of our geometry. So this is a constant value at the moment, but we can tell it to use an attribute, and that attribute is called blend. So if I just crank this up, and then if you see how if I move this now here, you can see that only the edges of my of the lightning stuff are being affected. If I adjust the input min, you can see how it affects the whole thing, and we're not necessarily changing the origin of our cells. Cool. So that's how I was doing the first part of this. So if we go here right now, all I added was a sphere, put some mountain thing into it, scatter a bunch of points, remove the points below the -0 in the y-axis, and then using the connect adjacent sop, using the same group expression with just a seed on every frame, and I'm just grouping literally a small portion of the points, incoming points. So there will only literally be 2 cells in our paths. So this point VOP is literally what we just did. It's just a point turbulence noise into a path cost attribute, and placing that path cost attribute into the point cost attribute of the find shortest path. And all I'm doing here is just bringing out the maximum of our cost attribute into the detail tab, into the detail attributes. And I'm not really using that for anything, I think. So, and here's the mountain sop with the blend attribute. And that's pretty much it, I think, for the first part of the lightning generating thing. All right, so so for the second part, I guess all I was just doing is adding some more breakups into the spline. So I've done a resample. As you can see with this spline, we don't have a lot of resolution onto our curves. So I added a resample sop, and it adds some more resolution into our curves. And also because of how the find shortest path is, it generates multiple points actually. I don't really like it, but it adds some nice look once we do the resample sop. It gets this very organic feel to the splines. I liked it, so I kept it like that. I didn't bother fixing it with fuse, with using fuse sop and the polypath sop. So I just kept it there because it looks nice. It was a happy accident, really. And on the resample sop, I've also put in the tangent attribute as the velocity vectors. So if you see, we've got velocities along the length of our splines. We'll use that for adding motion blur onto our curves, onto our lightning, and I'm also putting out the curve view attribute. So just using that curve view attribute for the blend for the second mountain displacement, and setting the width attribute for the rendering, and modifying some velocities as well, and multiplying some noise onto our width attribute for once we create the polywire at width. It will be just a constant width, but with the attribute adjust float, I'm just multiplying the width with some noise, so we get some more organic looking feel. Nothing special really. So next, this is just me multiplying down the curve along the curve view attribute. So if you see what the curve view attribute looks like, I've just put down a color sub here. Ramp from attribute curve view. It's almost like the cost attribute, but if you use the cost attribute though, the cost attribute is a little bit more even and uniform. So the reason why I use the curve view instead, because it's got these nice nice fall offs to each of the curves. It's more organic, I guess. So yeah, all right, so that's it. That's pretty much it, and there's nothing special in this setup. All these parts is just meant for the shader, so I'm just setting up the basic color for the lightning, and I'm just adding, you know, that technique we did in the previous setups by hacking the attribute adjust color and setting the gain here. The gain is using the width of our particles, so that on the thicker parts of the lightning we get more intense power or electric feel, and the less thick the curves are, the less emission we give out. So that's pretty much how I did the lightning thing. And the movement of this current one is just based on this top node here, the attribute noise of the sphere, the mountain. So it changes every frame. The seed of the scatter changes every frame. And at the moment, if you just visualize this, it doesn't feel very energetic. It doesn't feel very unstable to me, because the kind of dynamic I want to have is something really dynamic, something really unstable. If you just see this one, and with the reference they've also got this pulsating feel of the core. So I kind of applied it to my to the lightning as well. So all I did was just pre-transforming this, scaling it down, and this animate scale is just to scale it on the timing of when it's supposed to be in and when it's supposed to go out. And the switch is just switching between when we need to come off of the frame. If you just see here, it just completely removes me from the frame. So we got 0 points and some. And this scale modulate is what gives that energetic feel. Zoop, zoop, zoop. All right, so put down a sphere, and I'm just copying this scale modulate node. It's just essentially a transform node, which I've added an expression here. And all I'm doing is just doing a modulo operator on every frame, and the modulo operator, we can use it as a hack to do some looping thing. A modulo operator is just literally the remainder of it's just like a remainder operator basically. and it returns an integer. So all I'm doing is just for every 5 frame, if our remainder is 0, then we start at 0.6. But as soon as we get to 5, we'll have a uniform scale of 1. So this will change every 5 frames. So it will go 0.6 and 0.76, 84, 92, 0.6, 68. So it just cycles every 5 frames. So all of that is fitting the frame number, modulo operator 5, 0 to 5, 0.6 to 1. That's a very simple way to loop values. Okay. And next, all I'm doing is adding some random noise to our velocities, just so that we have a really crazy look to our lightning bolts. It adds a lot of details as well to the spline. So cool. And I think we'll talk about this next section of the core on a separate video. So I'll see you there. Cheers, bye.